Okay.
Welcome to the end of the summer presentation by the PoeTiX Automated Poetry Generation team. I'm Edwin, and with us we have Carrie, Jordan, and Ben. So before starting on our project, we had to consider what has been done in the past. The most popular previous work was a project known as Deep Spear, which used an LSTM language model and trained it on a poetry corpus to output lines such as "I saw me to the world, beggared of fame." This made quite an impact on media outlets. However, we believe it wasn't very good poetry. 2 years after that, there was automatic poetry generation from prosaic text, which was an RNN trained on prose, which would then generate lines backwards, beginning with a rhyming word. Next, there's automated generation of author stylized poetry, which was trained on individual authors and tried to replicate that. However, we are not able to reproduce their code. And finally, there's introducing aspects of creativity in automatic poetry generation, which used GPT-2 and clustered different words according to their emotional inflection.
Now I'd like to talk about our goals going into this project. Our goals were to create lyrical sonnets using natural language processing technology. Another of our goals was to surpass the works of prior poetry generation research projects that Edwin just talked about, and to emulate the language of famous sonnet writers, which was our focus throughout this project. Additionally, we looked at approaching a human level of meaning in poem as best as a computer can, and that was something we worked at throughout the semester through the usage of storyline and our dictionaries as well.
So consider a lot of that a sonnet has. For example, a Shakespearean sonnet has 14 lines composed of 3 quatrains, which is a stanza of 4 lines in the A-B rhyme scheme, and a rhyming couplet at the end. Each line needs to follow iambic pentameter, so it has to have 10 syllables alternating in stress. And ideally, we would have some kind of thematic consistency throughout our poems, so that the poems would be about the same subject, or the pronouns are consistent, or have the same meaning or theme.
So at the start of the summer, we used a fairly simple algorithm. So we would begin by selecting the words that were going to rhyme. And we would do this using a word embedding to ensure that there's some kind of thematic consistency. But only the rhyming words were related, because after that, we would just sort of randomly generate backwards until we had filled a template. And we would just randomly select a word that matched the part of speech and meter specified by the template. But there was no intelligent selection going on. It was just random.
So as we can see in this example, this was from the very beginning of the summer. I'm not going to read the whole thing, but there's several cases which definitely show some errors. So if theirs could colder this warm, or proving a oxen, and errors like that. And this was partly as a result of this random selection, which Ben was just talking about, and also because of some errors in our vocabulary and templates and so on.
So to move on from that, some of the problems that we had, as you can see in the previous slide, were issues with grammatical problems, such as a oxen. There needed to be an agreement between that to be an oxen, for example. Additionally, we had a lack of punctuation, which not only created problems grammatically, but also prevented us from having the human effect that punctuation creates in a piece of poetry. We also lacked thematic consistency between different lines of the poetry. And the templates had to be fixed were in meter, and this led to a deterministic output. For example, the only possible VBG in our dictionary with a 0-1 meter is proving. So any template that begins with a 0-1 VBG will start with proving, which created a lack of fluidity between our poems that we needed in order to create that human effect that we were trying to achieve.
So our process for creating these poems was that we would write hard-coded templates with the parts of speech and the meter specified. So for example, we would say in JJ, ABNN, PRPS, BBC, JJ, ABNN, the meter attached to it, each of those having a different part of speech attached. And then we would put it through GPT-2 to select the best words in each dictionary category to fill in these parts of speech. For example, that same template would become infused belief, they were undone beauty.
So let's talk about how we sort of improved the code and what we did. First of all, we just restructured code to be more object-oriented. This doesn't hugely impact our output. It was just sort of it made coding easier, better coding practices, etc. It makes working behind the scenes a bit easier. We also made sure that we have like a poetry database now that we go through for pairings of words. And that makes it less likely that we end up with strange pairings or grammatically unacceptable pairings. It can still happen, but we try to avoid those. We employ GPT-2 which is like a very large kind of the state-of-the-art NLP algorithm for text generation. And so now we use that to generate forward instead of originally, which was random generating backwards. And that gives us much more thematically consistent stanzas. They still aren't quite there where we'd like them to be because it still needs to meet the constraints of our templates, which can lead to some unusual decisions. And then the other thing we do that isn't mentioned on this slide is we've actually written something that can dynamically assign meter to a line. So it can find out which options are available for a given word based on what that means down the line, right? Because we don't want to pick a meter that means that later there'll be a word where we can't satisfy it. And that gives us a bit more diversity in our templates because the same template can take many different constructions now, as opposed to before with the problem we alluded to with proving.
Another thing we've been trying to do is trying to embody certain voices or specific authors. And so on the left is just our standard dictionary of words with about 24,000 words that are generally just the most common ones in English. And on the right is a stanza created from words that have only been used in Lord Byron's literature, and therefore we hope it gives it a more archaic and poetic feel, as we hope that he used more poetic words than the average person speaking English today. And so some of these lines, like it gives back the wilt atonement of their past, does certainly add to the kind of poetic sound of the stanza.
Now, this is something else we worked on, which was scenery poems, in which we inject a sense of scenery consistently throughout the poem. You can see here how we draw upon a forest in this scene, the butchered woodland, the wild decay, this consistent drawback to the setting that we have. And this created a thematic consistency that we didn't have before. However, this also represents a step within our progress of poetry. For example, the templates we're using here didn't have the punctuation that you'll see later on in our finalized product. And thus, they represent sort of a stepping stone as we moved forward with fixing these problems and also injecting the human feel through the quality of setting.
Yeah, so then we worked on our full poem and getting our product to the final stages where we've seen a lot of improvement. So this is an example, reversing back the strong self of her game, where all the badness of her cruel calls fell, her unrepentant hump might give her shame. She found the connoisseur of her gazelle. So we see a lot of grammatical improvements, a lot of better dictionary choices, some more consistency in theme, but there are still some grammar and word correlation issues in this poem. These mistakes do reveal the errors in our templates, in our dictionaries, and in our language processing abilities.
Yeah, so now the question is what do we want to keep improving? Because this is a project we're all going to keep working on. So one thing we want to do is iteratively improve the grammar and dictionary issues, because GPT-2 only generates from left to right, which means that when you're picking the first line, the first words of a line, you don't have an idea of what's going to come after them. And so it would be nice if there were a way to change certain words in a way that is reflective of the consistency of the whole line, to improve them after we've generated the initial line, so that we're using more of the information that we get as it goes further. Because GPT-2 can be used to score an entire line after it's generated. So then we can mess around with certain words within that and see how that affects the scores of the line as a whole. We also want to explore more narrative and character-based sonnets, which is kind of like the scenery stuff we alluded to earlier. We want to incorporate more poetic devices, so things like metaphor and simile, etc., but also just sort of phonetic things like internal rhyme and alliteration. We want to expand dictionary so that we don't just have Byron, but we can emulate lots of poets. We would also like to publish our findings at some point, and the code as well. And then we'd like to expand it to other forms of poetry so that we can do things like limericks, nonsense poetry, etc. Thank you guys for your time. We hope you enjoyed it.